In this video, we're applying the chain rule to a bunch of examples that have trig functions involved in them. And so you have to identify what's the outer function and what's the inner function. In the first example, I have tangent of x to the fifth. So x to the fifth is the inner function, and tangent is a function of that. So the chain rule says to differentiate with respect to that interior function. So differentiate tangent x to the fifth with respect to x to the fifth. In other words, I'm treating x to the fifth like a single variable right now. And when I differentiate the tangent with respect to that, I get the square of the secant function of that same argument, x to the fifth. The second part of the chain rule says now you have to tack on the derivative of that interior function with respect to x. You use the power rule for that and get 5x to the fourth. It would be nicer to write this with the 5x to the fourth out in front. And we're done. In the second example, the trig function is the interior function. So this is cosine x all raised to the fifth power. So I'm going to differentiate this thing with respect to cosine x. I'm treating the cosine x as a single variable thing. And that just gives me 5 times that thing to the fourth. You just use the power rule on that. And then the chain rule says now you have to tack on the derivative of the interior function. And that's negative sine x. And cleaning things up a little bit, I have negative 5 sine x cosine x to the fourth. In our final example, we have a cosecant of a non-trivial function of x. So the square root of x piece is the interior function. We're going to differentiate the cosecant function with respect to that, treating it as a single variable. And then we'll tack on the derivative of that. So here's what it looks like. Differentiate the cosecant with respect to square root of x. That gives you the negative cosecant square root x, cotangent square root x. Now tack on the derivative of square root x with respect to x. If I treat this as an x to the 1/2, I can bring down the 1/2 out in front, use the power rule. I subtract 1 from the exponent and get negative 1/2. And then cleaning things up, I move the 2 to the denominator. And then the x to the negative 1/2, that becomes x to the 1/2 in the denominator, but a nicer way to say that is root x in the denominator. And we're done with that one. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.